Hi, let's start with a new section, variables. What are variables and why do we need them? Let's look at SQL first. Generally, we query from this and want to do some other operations, but we cannot. For example, have you ever said that, I wish I could save that value and reuse it later? Yes, most probably you have said that for many times. Maybe the most important thing in plsql is saving some values for a while and reuse it back whenever we need. At that point, variables comes for our help. Basically, we use variables for temporary storage of data. We save it, manipulate it, and reuse whenever we need it. Besides, we can send them as parameters to the subprograms. We can use variables in almost everywhere of plsql. There are many types of variables that we can use depending on our needs. So let's look at what are these variables and where do we use them. plsql variable types. Every variable must have a data type. You need to choose which data type you will use, and sometimes you will choose the length. For simplicity, Oracle has categorized them into four main groups: scalar data types, reference data types, large objects, and composite data types. Scalar data types holds a single value with one type. It is the basic simple type. They can also be called as simple data types. Reference data types hold value which point to a storage location. They can be simply called as pointers. Large objects or LOBs are also pointers to other data items that are stored outside of the table, such as images, files, etc. Composite data types, these are generally called as collections or records. If you are familiar with another language, the main idea is pretty similar with them. For the students who are not, I can say that composite data types are the variables that can hold more than one value in it. They can be in different types or the same. We can reach any of them individually. Anyway, in this lesson we are going to talk about scalar data types. Rest of them will be taught in detail in our next lessons. So let's explain with the scalar data types now. I will show how to use them in using variables lesson. So let's start with the char max length. Character data type. We can think it as string or text. We can specify its maximum length up to 32,767 bytes. If we do not specify anything, default value is 1 byte. And varchar 2. An extended type of char type. The difference from char type is it is variable length. For example, if you specify 30 bits for char type, 30 bit is allocated anyway. Even if your text inside this variable is 10, you allocate 30 bits. But in varchar 2, 30 means the maximum length. If your text is 10 bits, only 10 bit data is allocated in the disk. Let's continue with the numbers. Fixed length number data type with precision and scale. If you write only number keyword, that means you allocate maximum value of number type. The precision can be between 1 and 38 and the scale between -84 and 127. But we should be careful while specifying the numbers. How? For example, if we create a number with precision 3 and scale 2, this means that my number will be 3 digits at total. 2 of them are the decimal parts. And binary integers, which is equal to PLS integer. Binary integer and PLS integer are identical data types, completely the same, but after 11G and including 11G. In older versions, they are not the same. Yes, their range are between over negative 2 billion and over positive 2 billion. They are not exactly 2 billion, but it's hard to say, so I simply say 2 billion. You can check if you wish. PLS integer and binary integers are faster and requires less storage than numbers. And in arithmetic operations, these are faster than numbers. And binary float. Binary float data type allocates 5 bytes of memory. Binary float ends with F char. For example, 2.07F. And binary double requires 9 bytes in the memory. Binary doubles ends with D keyword. It's some larger precision than binary float data type. But we should be aware that binary float and binary double data type computations do not raise exceptions. Therefore, you need to check if it will cause an exception or not. Then, Boolean data type. I think you know what is Boolean. It has true or false values. In PLSQL, it can be null too. By default, it's null actually. In other programming languages, by default, it's false. But in here, it's null. We should be sure about that. And date. Date type in PLSQL has the time of day and hour, minutes, seconds. To get the current date, you should use sysdate or current date functions. There are some type castings or some things to be careful with dates. But you will learn this later. And timestamp. Timestamp is an extension of datetime. In addition to date format, it has milliseconds with the precision that we specify. It's a more detailed date actually. And timestamp with time zone. This data type extends timestamp data type, including time zone. Time zone is the difference in hours and minutes between local time and coordinated universal time, commonly known as Greenwich time. It has a precision next to timestamp keyword. This fraction can be between 0 and 9. Default is 6. And timestamp with local time zone. Actually, this data type resembles with the timestamp with time zone datetime. The difference is when you insert a value with this data type, it's stored in database with database's time zone, whatever your database time zone is set. But when you query it, the Oracle server returns this value with your time zone of your session, your local time zone of your session, and interval year to month. This data type stores and manipulates intervals of years and months. We can set precisions for numbers of digits in year section. And the last one is interval day to second. This data type stores and manipulates intervals of days, hours, minutes, and seconds. These precisions specify the number of digits in the specified time value. Most probably, you will rarely use most of these data types if you don't really need it. So, I will not talk too much about this, but I will show how to use them in the next lectures. So, this is the end of the definitions of scalar data types. See you in our next lessons.